Completing the square is a process in which a constant is added to a binomial, such as x squared plus 6x, in order to create a perfect square trinomial. Let's consider two ways of understanding this process. First, a geometric reasoning for completing the square. Imagine a rectangle having an area equal to our binomial, x squared plus 6x. This rectangle would have a width of x and a length of x plus 6. And we could divide this rectangle into two smaller regions, a square region shown in teal that has an area of x squared, and a rectangular region shown in pink that has an area of 6x. Next, let's imagine that we divide that pink rectangle into two smaller rectangles of equal size. So each has an area of 3x. And further, let's imagine moving one of those smaller rectangles to the top of the square region. This would create an L-shaped region, which is outlined in the last diagram here. And notice that the width and the length of that L-shaped region are both equal to x plus 3. So we could convert this L-shaped region into a square if we add in an additional area shown in the upper right corner in orange. And the value of that area would be 9 because its length is 3 and its width is 3. So we can see that to complete the square on the area x squared plus 6x, we need to add an area of 9. Now let's consider an algebraic reasoning for this process of completing the square. Recall the equation for squaring a binomial. The quantity x plus n squared equals x squared plus 2nx plus n squared. Notice that the third term of that trinomial, the n squared, is related to the coefficient of the second term, 2n. To obtain n squared, we find half of that coefficient, 2n, and then we square the result. Therefore, if we want to complete the square on the binomial, x squared plus 6x, we can find 1/2 of 6, which is 3, and then square the result to obtain 9. And once again, we see that to complete the square on the binomial x squared plus 6x, we need to add 9. Now, why is this process of completing the square useful? Well, it can be used to write an equivalent quadratic equation that can then be solved using the principle of square roots. Before we use this process of completing the square to solve quadratic equations, let's just practice the process of completing the square itself a few times. So on this slide, we'll look at 4 different binomials, and for each one, determine what should be added in order to create a perfect square trinomial. Let's look at example number 1. We have x squared plus 10x. Remember that to complete the square, we first need to find 1/2 of that coefficient of x, and then we need to square the result. Well, 1/2 of 10 is 5, and 5 squared is 25. So 25 is the number we need to add in order to complete the square on that binomial. If we were to add 25, we would have a trinomial x squared plus 10x plus 25, which is a perfect square. Let's move to the second example, x squared minus 18x. Once again, to complete the square, we will find half of negative 18, which is the coefficient of x, and then we need to square the result. Half of negative 18 is negative 9, and negative 9 squared is 81. So to complete the square on that binomial, we would need to add 81. Let's look at our third example, x squared minus 7x. In this case, the coefficient of x is negative 7, so we would find half of negative 7, and then square the result. It's easiest to write this answer in fraction form because we can easily square the fraction negative 7 over 2. And by squaring both the numerator and denominator, we would see that the constant that would complete the square is 49 over 4. Now one last example, x squared plus 4/3 x. To complete the square, we will find half of 4/3, and then square the result. Notice that as we multiply these two fractions, we can do some canceling, simplify. So we see that we need to square the fraction 2/3. This means that the constant that should be added to complete the square is 4/9.